Hello everyone, and welcome to this latest webinar from IHS Technology titled 5G Backhaul, Challenges and New Architectures. Today, our panel will look ahead to the near future of the mobile network and the evolution of 5G transport solutions. Our webinar is co-presented by IHS and our partners Accedian Networks, Ciena, and ECI Telecom. My name is Alan Tatara, Event Manager for the IHS Technology webinar team, and I want to thank everyone for joining us. So before we begin, I want to highlight just a few features that are available for you on our webinar today. So the console that you're looking at can be customized in a number of ways. So you can enlarge the view of your slide area by either clicking on the maximize icon on the top right corner or by dragging down the bottom right corner. And of course you can open, close, move, or resize any of the windows that you have open on your screen and arrange the console as you wish. Now at the bottom of your console are a number of application widgets, and these contain additional features that are available for you, so please make sure you check these out during the webinar. One button I would like to mention is the Resource List widget, and this is the green button that has a document icon on it, and this is where you're going to find additional material about today's topic, including the downloadable slide deck from our session, as well as other valuable resources, including a special report from our analyst Richard Webb. And all these materials can be accessed and downloaded right from your console, so please make sure you take advantage of these during the webinar. Now let's discuss how you can participate in our webinar today. We've included a Twitter widget at the bottom of your screen, so you will be able to tweet directly from the console. And today we're using the hashtag 5G Mobile Backhaul. We're also going to have a live Q&A session directly after the presentation, so please make sure you submit your questions or comments at any time by using the Q&A box that's on the left side of your screen. And we will try to get to as many questions as possible, and any questions we cannot get to on our call, our panel will follow up with you directly after the webinar. So now let me introduce our panel. First leading our discussion is Richard Webb. Richard is Research Director of the Mobile Backhaul and Small Cells segment at IHS. Along with Richard, we have Scott Sumner. Scott is Vice President, Solutions Marketing at Accedian Networks. Also joining us is Brian Lavallee. Brian is Director of Portfolio Solutions at Ciena. And rounding out our panel, we have Dr. Scott Wilkinson, Senior Director, Portfolio Marketing at ECI Telecom. So welcome to all of our speakers today. Now let's get started with our presentation. So Richard, over to you.
Thanks, Alan, and welcome everybody. Thanks for joining us. We're going to start today by looking at 5G so far to see what we know and to give some context when we look at the challenges in backhauling a 5G mobile network. So when we consider 5G, we might not know exactly what it is going to look like, but we can say it's not necessarily going to look like a straightforward transition from the previous generations of mobile technology. And thus, in the backhaul network, perhaps we need to think a little bit more beyond a simple evolution of the backhaul and think more in terms of a revolution. And whilst the specifics of 5G in terms of technology and architecture still remain undefined, there is some growing consensus around some of the characteristics that will underpin 5G. In part, these revolve around things like gigabit access speeds and sub-millisecond latency, but also include density, devices, coverage, power consumption, and so on. And all of these characteristics impact the backhaul network. The capacity that will be required, the scale of radio endpoints, the number of devices, the type of devices and applications and services, the overall scale and complexity of traffic, and the intelligence that the backhaul network needs in order to be able to cope with that. And if you take all of those things into consideration, one thing is certain. If we continue to build backhaul as we currently build it for the 5G environment, it will not cope. So just to kind of follow up on the previous slide, when we look at 5G in terms of where it could take the mobile service environment, the two key requirements that I mentioned previously that all potential new services in the 5G domain have in common are, of course, that very high capacity and very low latency. And for backhaul, this means it's not just about how much capacity mobile operators add when deploying 5G, but where in the network they add it, what technologies underpin it, and how the network is going to be managed to cope efficiently with the volume and complexity of that traffic. So hopefully that gives a little bit of opening context for 5G, just to whet the appetite, get you thinking a little bit about what 5G means in terms of architecture, what it could mean in terms of backhaul, and that's what we're really going to kick into in the meat of today's presented content of the webinar. So let's look firstly at some of the challenges that 5G creates for backhaul, and I'm going to start by bringing in Scott Sumner from Accedian to have a look at that for us. Scott, over to you.
Thank you, Richard. Great to join everyone here today. One thing we want to look at here in terms of the challenges for 5G backhaul is really the size and scale of what we're looking at in terms of the number of sessions that are going to be running over that backhaul network. So the GSMA goes beyond the predictions they've shown there in terms of the requirements and the type of applications to show a little bit of the scale that we can expect that may occur running over these networks. So they're expecting by 2020 or early 5G networks, 4 times more apps per device running concurrently, 100 times more devices, and over 1,000 times more bandwidth. And if you sort of multiply these out, realize for a mobile operator or for the backhaul itself, there's really more than 1 million times more concurrent sessions than today's backhaul network would handle to manage and make sure that they coexist properly. And what a lot of operators are looking at when they get into this domain is that it's clear it's starting to get beyond the control of humans to actually manage and optimize each service over this shared network without some form of automation or SDN. One of the other challenges that we've seen in number of the tier 1s that are starting to roll out pre-5G networks is that there's new interdependencies between what used to be fairly straightforward backhaul metrics, measurements, or performance criteria. So with coordinated multi-point and carrier aggregation and more pieces coordinating together to deliver effective throughput and results to the end user, we're starting to see emerging relationships between what were used to be uncoupled metrics. So things like loss leading to throughput, so just very small amounts of loss leading to dramatic amounts of throughput where the customer is severely impacted by small amounts of packet loss, or also things like loss burst, which is a new kind of problem where a series of packets is lost and a significant outage can occur based on control plane signaling lost. Also similar relationships occurring now between delay and throughput, which are really related to multiple antennas coordinating themselves in real time through an X2 interface so that they can transmit effectively to the end user and maximize bandwidth. I'll pass this on to
Thanks very much, Scott. So I'm going to bring in Scott Wilkinson now from ECI to talk a bit more about 5G services and some of the requirements. Scott.
Sure. Thanks, Richard. So as you heard earlier, Richard said we really don't know exactly what 5G is going to look like. But what we know is that really with 5G, it's all about what we're going to do with it. It's not necessarily about the antennas and the technology behind them. It's really about what we want to do. So 5G really is about services, and that's the biggest change from 4G to 5G. Not necessarily the technology, although that will certainly change, but what we want to do with it. We're moving from a focus on data and connectivity to high-density video streaming as something that you expect out of it for things that are higher speeds, lots of things attached at the same time, very low latency, and all of those are being driven by services, not necessarily by somebody just coming together and saying, these are nice things to have. We're looking at what we really want to do with it. So if you look at what those requirements are, there are different groupings, really, of services. There's the range of services. We want to be able to do a lot of different things with the 5G network. Enhanced broadband, of course, is the one that's obvious, but then there's a lot of low latency, high reliability kind of applications people are talking about now. High density, especially with Internet of Things. Mobile edge computing, which we'll talk about more and more. You have to have a much more responsive network for that. On top of that, you got to have better quality of services, which is timing and latency, service level agreements now over a wireless network, which is something we haven't really seen before. And then security is something that's going to become ever more important as we have more endpoints, more applications running on the network. Now there are more entry points for bad players and security events to get in. Security becomes much more important. All of this, of course, lays across the idea that it's got to make sense economically. You've got to have good efficiency of the network so that more things can run. You've got to have a low total cost of ownership, so more bandwidth at lower cost with low power consumption. And you really want this all on a converged infrastructure so that the mobile backhaul infrastructure is easy to manage with all of this stuff going on it. So Richard, I'll hand it back to you.
Thanks very much, Scott. Now I want to bring in Brian Laverly from Ciena to talk about one challenge in particular. Brian, over to you.
Yeah, thanks, Richard. So I do agree with Scott that the services will dictate the network needs, but at the same time, the network technology will dictate the services that will actually be possible. And there's a lot of talk about some of the newer applications that will generate new revenue streams, and that will allow the mobile network operators to actually fund this 5G deployment. In my mind, one of the biggest performance goals that will probably be one of the larger obstacles is the 1 millisecond end-to-end latency. So reaching download speeds of 1 gigabit per second up to 10 gigabit per second are formidable goals, but I have full confidence in my wireless brethren. There's been a lot of trials where they're getting very close to that download speeds today. But I think the 1 millisecond end-to-end latency, it affects a lot more than just the technology. It's a network architecture shift. It's where do you put your content. It's when we consider the 1 millisecond end-to-end latency, that's from the top of the OSI stack, the application layer, to the top of the application layer sitting on the other side of the link. And that brings up quite an interesting scenario. So what's the network implication? If you take into account the processing time or latency on a new 5G smartphone, which I'm showing here in yellow, and the processing time of the actual radio equipment, you're looking at probably around 1 kilometer of distance between the actual content being served up to the end user and his mobile device. So the question now arises, where do you place your content? And that raises up a whole bunch of new concerns that I've personally been involved with multiple MNOs. And the question is, do they start building out macro cell micro data centers? So putting content, functions, and applications much closer to the end user, which is probably at the base of the tower or at the nearest switching center. And if that is the case, the question is, will the densification, cell densification that you'll need for 5G, how many of these micro data centers do you actually have to build out? And I think it becomes more of an economic problem than a technological problem. And this is where mobile edge computing that Scott mentioned earlier actually comes in. So you can bring the content and the applications much closer to the edge, and then you can start to use some of the virtualization techniques and applications that are also a part of the whole virtualization revolution across the network. The question I have in my mind, will the new 5G applications justify these rather substantial content relocation investments? One of the beauties of 5G is it's not meant to outright replace 3G and 4G, but more complement it in areas where you need the performance specifications of 5G. So you don't have to put content everywhere and applications and functions closer to the user, just where you plan on selling that service. Back to you, Richard.
Okay, thanks very much, Brian. So hopefully we've given a sense of some of the inherent challenges in 5G mobile service domain and a little bit of what that means for backhaul. But now let's have a look at how operators can address some of those challenges. Staying with Brian from Ciena to begin with, I want to look at how we align backhaul with these rising performance expectations. Brian, back to you.
Thank you. Yeah, so what we're going to do on this chart here is we're going to actually map the wireless performance targets for 5G into the wireline side or the backhaul side. And one thing to keep in mind is most of the content that's being driven over these mobile networks, and especially when we start getting into the higher download rates, is probably going to be video-centric content. So you're actually talking about not just the mobile backhaul side from the cell tower to the mobile switching center, but you're probably talking the path all the way back to the data center, wherever that may be. So if you look at the first three wireless targets here, the 10 gigabit per second maximum download capacity, the 1,000 times more bandwidth per area, and the 10 to 100 times more devices, what we're basically talking here is about an astounding jump in capacity. I think we have the technologies available on the wireline side that are being deployed today. So we have the 100 gig optics, and 100 gig in the next couple of years will probably be seen as rather slow. Many vendors, including ourselves, are talking about 400 gig and beyond, 200 to 400 gig and beyond. We have DWDM techniques, and we have the coherent optics as well. So I don't think from a capacity perspective we'll be in a pinch. The next one here, the 5 nines availability, it's attributed to 5G, primarily because a lot of the new applications that are to be run over this cell network have to have a much better availability target than is available today on 3G and 4G networks. And there's a wide variety of technologies available today. There's SDN-based intelligent networks where you can reroute traffic around the faults and failures. You have some generic protection schemes, 1+1 protection, G8032, intelligent mesh, rings. I don't think that would be a problem. We can probably do that today. The question is, what are the economics of giving you 5 nines availability everywhere across your network? If we could do that today, we could. It's just, does it make economic sense? The next one is 100% perceived coverage. Again, that'll entail a lot more cell sites, much more densification, and much more backhaul links. So that's also possible today. That's an economic question. The 90% less energy. So, using new chipsets, delayering your network, simplifying your network, getting rid of layers you don't need in parts of networks where it doesn't make sense. Removing all the copper, mobile backhaul, which takes an enormous amount of power. And also using smart self-optimizing networks. So in non-peak hours, you could probably turn off some of these cell sites entirely and save the energy. And when everybody wakes up and starts going to work the next day, you can turn the cell sites back on. So there's a lot of plays there where you can save a significant amount of energy. When we look at the 10-year machine-to-machine battery life, we're basically talking here about the sensors. This is the Internet of Things, the 20 to 70 billion of them, depending who you believe. But all the forecasts are optimistic. This could be a sensor sitting in a farmer's field, waking up every hour and taking temperature and humidity measurements. So although it'll be minimum bandwidth that'll be placed on the cell network per thing, we're talking 20 to 70 billion plus things, so it does add up. And you'll also have to have different service level agreements for these small things versus some mobile user downloading 4K video. And then we have the 1 millisecond latency, which we talked about earlier. And that's more of an architectural decision, but there's also some of the innovative technologies and architectures being discussed, such as mobile edge computing, cell caching, and also the content delivery intelligence that's already in play today with the likes of the over-the-top players that could be adapted. Once you have all these technologies and capabilities available in the network, you need to have some multi-domain service orchestration engine sitting on top. You want to be able to move bandwidth around on the fly. If there's an event in the city where suddenly everybody in a given geographic area is downloading or creating a huge capacity demand, you'll be able to shift a lot of the capacity over to that part of your network, and you can shift it on the fly based on time of day and usage. And then once you have that multi-domain service orchestration engine that you can manage the network from the cell tower all the way back to the data center and everywhere in between, then you can start delivering some of the mobile network applications. And a big one would be the big data analytics, the machine learning, where you can have the network over time pull in a lot of the data that Scott from Accedian mentioned, which I think is critical, and I agree with him. A lot of the metrics that can be pulled out of that network will be pushed into that big data analytics engine, and it could give some pretty important information back to the mobile network operator, how he can optimize his network, not just on the fly, autonomously, but also in the future, just based on traffic utilization. We all hope to have the best modeling in mind, but we all know once we deploy a network, especially when you're talking mobility, people don't stay in the same place. Having some autonomous learning engine sitting inside your network and optimizing on the fly is something that's coveted by all the MNOs I've talked to. So I hope that gives you a good idea. I'm an optimistic person by nature, and I think if you want to get something done, tell the R&D community that it's impossible, and then they put on their creative hats and they always come up with some pretty cool ideas. If you think about it, 30 years ago you used to have to go to the library. Today you pretty much have the entire library of mankind in your cell phone. The library comes to you. So I'm optimistic, and I think technologically on the backhaul side and even on the aggregation side back to the data centers, I don't think we'll have significant hurdles. Back to you, Richard.
Great. Thanks very much, Brian. So now turning to Scott Wilkinson from ECI. What considerations are there in preparing the backhaul network for 5G?
Sure. So I think you saw a nice description on the last slide of the technology, especially the hardware technology and the other that's going to have to be built in the mobile backhaul network. What I'm focused on here is we talk about intelligent networks being more software-based. So what solutions are available from that paradigm that really fit with the mobile backhaul for 5G? And again, going back to the icons from before, the range, quality, and security, on top of a low total cost of ownership, With range of services, there are things available now. We're talking about things like network slicing, and pretty much any presentation you go to on 5G will have to mention network slicing. I think it's a requirement at this point. But that's the idea, that you can now take the network and break it up into different slices based on what the application requirements are. As you heard a minute ago, not everywhere is going to need not every place in the network is going to need every feature. Network slicing allows you at certain locations to dedicate parts of the network to different applications. It's also important to talk about open networks. Now we're talking about networks that have millions and millions of different interfaces on them. Those interfaces themselves need to be open, but also the control inside the network has to be open. When you start talking about a network now that has lots of different pieces that have got to work together that efficiently, that's really where open networking starts to come in. We start talking about things like SDN and controllers working on top of that. NFV is going to be critical. We've heard it said several times, not necessarily in this call, but in other calls, that NFV is going to be absolutely critical to making mobile backhaul work for 5G, just because of the services having to be closer and closer to the edge, as you saw the 1 kilometer distance there. And then for quality of service, there's caching, but there's things on top of caching as well. You have to be more intelligent with caching. You've got to have certainly the content closer to the edge so that you can meet the requirements, but you've got to be a little bit more intelligent about that. And SDN allows you to do some of that, and keeping a flat architecture allows you to do that. If you see the network diagrams for 3G and 4G, what you'll see is when they're typically drawn for 5G, they look flat. Now, that's not to say that those network architectures can't be built today. It was mentioned earlier, I believe by Richard, that the networks of 3G and 4G backhaul don't necessarily change completely overnight to a 5G backhaul network. The things that we're talking about doing here for 5G can be done with 3G and 4G as well, so you can already start to build that flat architecture. And then, of course, security is always going to be important. Encryption is the most basic of security, making sure you encrypt everything, but also having some of the big data analytics, as was mentioned by both of the previous speakers, being able to look for anomalies, looking at things that are happening at the endpoints, looking at things that don't look right, and tracking those things down before they get into your network, because there's no way, as we've said several times on this call, for humans to be able to track that. All right, back to you, Richard.
Thanks very much, Scott. So picking up on some of what Scott Wilkinson said, we've heard a little bit about SDN getting mentioned, NFV, and also analytics, but I'm going to hand on to Scott Sumner from Accedian to talk us through some of that in a little bit more detail. So, Scott.
Thanks, Richard. Yes, really one of the first things that needs to be done to get big data analytics to provide some steering or some control to these new 5G backhaul networks is to make sure there's a uniform ability to instrument it and see what's going on in terms of the network state. So what's been happening in parallel to the evolution of 5G is an evolution of instrumentation itself to become more virtualized. And you can sort of see here on the left side there's a stack that's very similar to the SDN architecture in terms of data plane elements, agents, for example, control, and then some orchestration on top. And the idea here is to use the network infrastructure itself as a source for the data to be aware of the quality of service in the network, the performance of each application or each network slice, as we've been mentioning, and bring that data, analyze it, extract the QoE or the end user experience as well as the quality of service of the network itself, mix it with the subscriber state, and get this into a big data lake or some in-memory processing. And there's really two sides to this. There's sort of the big and deep data that gives you the subscriber trending and potentially opportunities for new services and upsell. Then there's the fast data analytics that would potentially be run in, let's say, a RAM cloud and running an in-memory processing that would allow real-time analytics and machine learning to establish the best path for SDN control and how to orchestrate services into the control plane. And this would feed back into the need for particular network metrics in different parts of the network through open interfaces that would then close the feedback loop. The other type of technology that's emerging today, aside from analytics, is really the ability to pull every layer and every location back into centralized analyzers. And this will increase the visibility of these systems in SDN control and analytics to make sure that they're using full network state information from all corners of the network. So if you look at where analyzers typically are today in a mobile network, for example, they're sitting inside the EPC and they're connected to the various gateways so they can see, let's say, mobility, serving gateway, packet gateway, but they're really only seeing conversations and threads and sessions from that central location. So One example would be if there's a VoLTE call failure or a quality issue that degrades as the call itself traverses the network and starts to degrade along the path. There's no visibility into where the location of these failures may occur. So one emerging technology now is the one that we're seeing a lot of mobile operators adopting towards remote packet capture. So the ability to remotely access any session or thread, any call or any control session, and bring that data back to analyzers that can then become location aware, so they can isolate network problems and quality of experience problems in real time, but then also feed that back to SDN control as part of the overall fast analytics. So this is one more place where building a real breathing intelligent network is starting to become a reality. Richard, pass it back to you.
Thanks very much, Scott. And just to wrap up this section, handing back to Scott Wilkinson, something you mentioned earlier, perhaps you can pick up on, NFV. Perhaps you can give us a little bit more granularity on what that means for Backhaul.
Sure. I think I like what Scott said. It's making the network a living, breathing network so that you have intelligence out there in the network. NFV is certainly a big part of that. And as I said, it's been suggested that 5G backhaul really isn't going to work without NFV working well. There's several applications that have been talked about, everything right to left there, from the application management itself, security being part of the NFV, service level agreement monitoring can be part of the NFV capabilities. And for those of you who don't know, NFV essentially says taking functions that used to be in a separate box and virtualizing them and running them on a compute-intensive platform that can sit out in the network and run that function virtually without having to stack lots and lots of hardware on top of each other. But once you have that capability out there, now you can start saying, well, I have this compute capability. Maybe I should be able to do more than just what was done in the past. So, for example, caching in the past, you typically looked at and said, well, this is coming from the same source. It's got the same IP address. It's got the same file name. I can cache it here, and that way if somebody asks for it again, I have a local copy of it. But now we're able to do a lot more than that, things like deduplication. We can actually look at the content itself and say, you know, this isn't exactly the same thing that I saw before because maybe the URL is different, but boy, it sure looks like the same video of cats that I saw last time. Maybe it's the same thing. And now with that intelligence out there, that NFV out there, we're able to more intelligently understand that the stuff that's happening on the network may be duplicated from a variety of different places, and we can intelligently cache that with deduplication. We've done some tests with some of our mobile backhaul networks, some very large ones in India, and saw 15 to 35% traffic optimization off of that. So the whole idea of having a living, breathing network, a network that is more intelligent out there at the edge so that you don't have everything consolidated in the middle, allows you to meet all of those service requirements that we talked about earlier. Richard, back to you.
Great, thanks very much, Scott. Before we move on to the next section, just a quick reminder to all our audience that you can submit questions at any time. We will be getting to the back end of the hour Q&A section. We'll be going through as many of those questions of yours as we can handle in the time left available to us. So please do send them in just via the Q&A part of the webinar interface. Thank you very much. Okay, so hopefully Brian, Scott, and Scott given a good overview of the solutions for next generation backhaul, what it's going to look like in that 5G environment. But let's keep going. Let's have a look at what this might look like specifically from an operator's perspective. Firstly, I'm going to bring in Scott from ECI. Sorry, I beg your pardon, Scott from Scott from ECI.
That's right. Well, this is just an overview. We've talked about all these different enabling technologies that get us to the low latency and the high bandwidth and the high density, which are really the enablers of 5G. So on top of that platform, we start building a variety of applications. And of course, it'd be crazy for us to say that we know all of them today. Certainly when iOS came out for Apple, they had no idea what all the applications were. The idea now is that this network with this enhanced mobile backhaul network is going to be able to allow lots of different things to be built, things like smart cities. And smart cities means a lot of things to a lot of different people. I know it's kind of a nebulous idea, but just about everything people have said with smart cities will be enabled over the wireless network. Augmented reality is a really interesting one. Edge computing, I'll talk about a little bit more. That's the idea now that the network becomes part of the compute platform. We certainly know video streaming, and that's going to be a majority of the network, but it only has certain requirements. High bandwidth, for example, it doesn't necessarily need the high density that the Internet of Things does. And the Internet of Things, of course, is what's really driving this idea of high density. But once we have it there, there are a lot of other applications that we can start to consider on top of it. The one application, though, that we've mentioned several times here that I wanted to talk about a little bit more is mobile edge computing, because that's a really interesting idea, and it really fits into many, many others. For example, smart cities and intelligent transportation and enhanced operations for things like delivery. The idea behind mobile edge computing, if you look at the ETSI website, is to offer cloud computing capabilities and essentially make the network itself part of those cloud computing capabilities. In order for that to happen, you have to have everything we've talked about, ultra-low latency and high bandwidth and all the things that go around that. But now you're talking about the network itself becomes not an impediment or just a connection. It's actually part of the compute for mobile edge computing. And that's really exciting, and that's, rather than being an application itself, think of it as a platform now that's open for all sorts of other things to be built. And that is really where the future of this 5G and the backhaul behind it is going. So Richard, I'll hand that back.
Thanks very much, Scott. Now I'm going to hand over to Brian from Sienna again. Brian, how can operators add value to backhaul?
Thanks, Richard. Yeah, so Scott's been giving a very good overview on the services side. I'm going to step back a little bit, and I'm going to look at the mobile backhaul side again. And it's worth it to notice that if you are an MNO and you control everything, so you control from the wireless interface all the way back to the data center where the content is being served up, and everything in between, you would design a network quite different than if you were buying mobile backhaul wholesaled services. So in North America, this is actually a common practice. I know in some other parts of the world it's not as common. But if we look at what's happening today, when you have a traditional mobile backhaul service, and it's worth noting that this mobile backhaul service can come from a third party, where the MNO will actually pay for this backhaul service in regions where they don't have fiber, for example. Or it could be a mobile backhaul service from the Wireline division of a large Tier 1 carrier who's providing that Wireline mobile backhaul service to the wireless part of the division. So they have demarcations so they can ensure whether you're paying for it or you're getting it internally for free, that the service is actually meeting the SLAs that's being promised. So on a typical mobile backhaul service today, you have three media options. You can get fiber, you can have copper, and you can have air, basically a millimeter or microwave backhaul, for example. If we look at 5G, and we're talking about 1 gigabit to 10 gigabit per second download speeds per user, you start to look at copper and air interfaces with a little bit of a question mark, I guess. Fiber is the one that has essentially unlimited bandwidth in this application, so that'll probably continue going forward. And if you have dark fiber, you can have it managed or unmanaged. Unmanaged means it's just dark fiber, whether it's cut or not. You have no way of knowing if it's cut or if the cell tower at the other end is actually dead. So you have unmanaged, and then you have managed, where you can send a separate wavelength down that fiber, and you can actually detect if your fiber that you're selling, your dark fiber, is the problem, or the cell tower radio on the other side, for example, has gone silent. Or you can offer, move up the stack. You can offer Ethernet, MPLS, TP type services. You can do performance metrics, packet loss, latency delay, all these type of measurements. And then you have also IP, MPLS, VPN, where you're doing a peer to transparent mobile backhaul service. This is what's available today, but if we look at 5G going forward, you're probably going to have the media itself will probably be fiber-based, and then you still have the opportunity of those three services sitting on top. But if you think about the NFV that Scott 1 and Scott 2 were talking about, this brings a whole other wealth of opportunities. So if you're the network operator who owns everything, this is a network optimization activity. For example, you can have a Ethernet demarcation device with an x86 server sitting in that same platform, and then you can start to get rid of some of the boxes that you have at that cell site, for example. A firewall, encryption, IP routing. You can put a software-based routing. Most cell towers have routers on site. They don't have to be very large and powerful, given the capabilities that they're actually using. So that would be one good opportunity to virtualize that function. So now if you're a mobile backhaul service provider and you're selling that to the larger MNOs, you can offer not only media options and SLA guarantees using performance metrics, for example, Ethernet performance metrics, but now you can start offering some other services sitting on top of that. If you're the MNO itself and you're controlling that box or that platform, then you can do a whole bunch of these VNFs that I have listed on top, and you can start to simplify your network. You can start getting a lot of those separate appliances at each cell site. You can collapse it down into one device, and I'll talk a little bit more about that later. Back to you, Richard.
Thanks very much, Brian. So now to pick up on something that we've heard a little bit about already, I'm going to turn back to Scott from Accedian to go into more detail about quality of experience and what that means for services.
Thanks, Richard. I think just building off what we were just hearing from Brian is really whether we're creating new virtual network functions in the network using mobile edge compute, or we're creating some sort of new network that's going to use coordinated multi-point or different antenna technology. One thing that needs to be done here is that you're going to have to watch through the full life cycle of how you introduce these services and make sure they work for the first time, and then assure them, make sure the quality of experience is as high as possible for the end user. So just taking a quick example here from Telefonica, and we'll look at some other operators in a minute in terms of other use cases, but one of their best practices here is to go out there and sort of assess the readiness of their network for any new technology that they're incrementally laying on top. So do a simulation, make sure the network is working, and if there's any bottlenecks that can be identified, find those and fix them before you actually roll out the service to end users. And then just before you do that, you check and see if everything's functioning properly before you flip the switch and bring it live. Of course, that's always going to be followed by a continuous monitoring, fault management, the type of information that's required for SDN controllers and intelligent analytics. And this is kind of the step that allows the operator to close the loop and make sure that their predictions, their trends are following as they expected in terms of tracking per user quality of experience and making sure those are maintained. And I think that's a key point, is that we're not really as interested in making sure that the network mechanically is working perfectly for every possible different dimension and metric. Really, at the end of the day, the user experience is what has to be served here and will be the ultimate judgment of whether the network was deployed properly or not. In terms of SDN control and how the network state is used to do coordinated multi-point or intelligent backhaul pathing, we'll take a look at a case study here that SK Telecom has presented in terms of how they were able to measure the network state across all of their different backhaul links and then move traffic around them. So these would be either network slices that are serving multiple applications concurrently, or data from even single sessions that would be split or aggregated over multiple links, which could be microwave or dark fiber or regular Ethernet, for example, as required. And all of this is basically possible by measuring each link's performance and whether each link is suitable to pass backhaul traffic for a particular application. So if you imagine that one link might be very slow but has very low latency, it might be quite suitable for sending control plane signaling, whereas another link might be fairly high delay but has a lot of bandwidth available, which might work very well for video streaming. So it's a matter of matching up the characteristics of each application or service to what's available in the network so that you can use every ounce of capacity as efficiently as possible, so that backhaul networks don't have to be have oversubscription to serve applications. Taking the same use case and taking the next extension of SDN, which is really NFV orchestration at the service of the SDN controller, the same type of logic is being applied by operators to how they scale up virtual network functions, where they position them in the network, and making sure that their resources are scaled up enough to support good quality of experience. So with a number of different Asian operators, what they're doing is basically monitoring the NFVI, so the network function virtualization infrastructure in real time, making sure that the service chain and the path between services that may be distributed across the network are monitored in real time, and then comparing that to the user experience. And as they see some degradation in user experience, they may move some network functions closer to the user, or they may scale up the compute resources. And all of this would happen based on the network state that's being collected from the network in real time. Richard, back to you.
Thanks very much. One quick reminder that we will be coming up to our Q&A section, so please do keep those questions coming. We've got some excellent ones already coming in, so thank you for those. Now we're going to take a quick look at the approaches and the solutions offered by the companies represented by today's panelists. So let's go in alphabetical order by company, starting with Accedian. So back to Scott Sumner.
Thank you, Richard. Just a quick summary of what Accedian's been up to recently. We've been transitioning our 10-year-old portfolio of basically leading-edge monitoring technology and virtualizing over the past few years to the point now where we offer a fully virtualized solution that scales carrier grade but still maintains the precision of the hardware pedigree that we've had deployed worldwide. And this really involves the architecture I was showing you previously, where we have a variety of data plane elements, centralized controllers that can sit in cloud or mobile edge compute infrastructure, and then an overall orchestration layer that would allow interaction directly with analytic systems, big data systems, or SDN control systems, really with the objective of closing this loop between having visibility, getting that as a feedback loop that will help service providers establish automated or optimized control at the service of the customer experience. And this is critical to our customers just because competing on price is no longer really an option as you move towards 5G. There has to be some proof that performance and user experience is exceptional, and that's really what they're planning to differentiate with over the next couple of years. We've also introduced a Flow Broker, which is the first distributed packet broker, which is of interest to measuring true customer experience across the entire network. So something to look for in the resources we have attached to this webinar today.
Okay. Thanks very much, Scott. And now Sienna, so handing over to Brian.
Thanks, Richard. So Sienna, for those who don't know, in terms of the packet over fiber-fed mobile backhaul in North America, Sienna has approximately close to 100,000 of these sites that's served by our gear. And that's the carrier Ethernet product portfolio that we have. So what we've done is we've taken that battle-tested, proven technology, and we buried it into a platform with embedded x86 server capabilities. So I talked earlier about being able to use Ethernet demarcation to do a mobile backhaul service, the SLA guarantees, and make sure that the SLAs that are required for the applications are actually met. But now you have the capabilities of moving some of those VNF capabilities or functions into that same platform. So for example, you could remove that IP router and instead use a software-based IP router, load it onto this platform that you see here, shown in this diagram, and you can start simplifying your network. So again, if you're an MNO and you control everything, this is an opportunity to simplify your cell sites, get your costs down, get your OpEx down, your power, your complexity. And if you're a mobile backhaul service provider, you can still use the Ethernet demarcation platform that's available or capabilities available in this platform, and now you can start offering some of the VNF capabilities as well. We talked a lot about SDN and NFV, and there's a lot of consensus in the industry, and I'm a firm believer as well, that to get to the 5G intelligent self-optimizing networks that we're planning on having it being able to do a lot of things, virtualizing the network from end to end is the only way we're going to get there. If I go to the next chart here, I talked earlier about the NFV part of the virtualization. Now we're talking about the software-defined network part, or what we call it, it's our Blue Planet portfolio, which is a quite broad portfolio. But one of the biggest advantages of this is the multi-domain service orchestration. So we know, and our MNOs know firsthand, that a lot of their network is very diverse. It's coming from very different vendors. Even within the same vendor, there's multiple different products from the same vendor, and some of these products were acquired from other companies. So the network from the tower all the way back to the data center is quite complex, is very diverse, and we have a multi-domain service orchestration engine where we're able to manage services on the fly from end to end. This could be using a human touch, so somebody sitting at a keyboard and turning up these services, or through open APIs, and it could be done using machine code. So now we start to see some of the machine learning capabilities can be built into the platform. So we have the WAN orchestration engine. We also do support using open APIs third-party controllers. So if another company is in that mobile backhaul network, we're able to communicate with it and turn it into a virtualized resource. We have the NFV management and orchestration engine, where you can push out those VNFs to the edge. You can even update them on the fly. You can change them. You can modify them. You can try out different VNF partners. And then we also have the whole data center re-architected as, a central office re-architected as a data center, which is a case taking place around the world where data and content, video content in particular, is driving the network. And it's the same over the mobile network. If you look at anybody sitting on their mobile phone crossing a street during traffic, they're watching some video. And that is turning these central offices into data centers. And we have a hardened ONOS controller that supports that as well. And then we have the applications that will sit on top, such as the Blue Planet Analytics engine, where you can take a lot of the data that the two Scots have talked about, and you can put it into an engine and have the network spit out some very useful results based on the enormous amount of information that can be pulled. Back to you, Richard.
Thanks very much. And finally, ECI. So back to Scott Wilkinson.
Sure, thank you, Richard. So for those of you who aren't familiar with ECI, we have built some of the largest mobile backhaul networks in the world, very, very dense networks, and that's basically built off of our packet optical transport platform. We like to show it as this concentric sets of circles where in the middle we have transport, our packet and optical lines, Neptune and Apollo, but also an NFV line and Mercury. One of the things that we've sort of prided ourselves on is making NFV and SDN applicable to people who haven't had a chance yet to upgrade their entire network. So we have built-in migration to those networks, and you can see that if you look beyond just the transport to the next layer, which is control. We have, of course, a standard NMS, a mono for NFV, and then we also have an SDN controller. But what's more interesting, I think, for us is beyond that, the apps. That we already have SDN apps available. They can do a lot of different things for your network, especially with automation, which is, of course, where you really want to get to with SDN. And those are available for people who have upgraded their networks to the new paradigm or have not. And then our DNA is really in security. ECI has been around for 50 years. Started out doing a lot of things with security, and that's still built into all of our platforms. So rather than showing that being across the entire layer, we just show it as sort of the surrounding idea of LightSec and security across all of it, allowing you to be able to do a lot of different things across all the network and keep them all secure. Thanks, Richard.
Thank you very much, Scott, and thank you to all our presenters. That concludes the presentation part of the webinar today. So just going to wrap up with a few concluding comments before we move on to the Q&A. So we heard that backhaul's becoming more complex. I don't think there's any debate about that. 5G is going to continue driving demands on the network even higher. That's going to, in turn, drive the need for dynamic backhaul. Monetizing 5G is going to require performance, and that's going to create challenges in terms of capacity, latency, network diversity, and so on. SDN and NFV will be fundamental in unifying backhaul, driving efficiency in terms of performance and cost control. And if we can do that in the backhaul network, there will be new service opportunities derived as well. NFV-based instrumentation, as we heard, with central control, is going to play a key role in particular in utilizing the network effectively. Data analytics will help drive smarter real-time leverage of the network assets and most important, that visibility into the network that underpins network performance monitoring. So it's a whistle-stop. There's an awful lot we've covered, and I know you're going to have lots of questions. So hopefully that gives you some food for thought before we dive in. And without further ado, I'm going to kick off with some of your questions, and I'm going to put those to our speakers in turn. So just to start off with, I hope this particular audience member is not overly anxious by what we've said, but here's a question. What do we need to stop doing that we've been doing in backhaul design so far? What do we need to start doing in anticipation of 5G? So hopefully we haven't pressed too many panic buttons. Which one of our speakers might want to tackle that to kick off?
Yeah, this is Scott from Accedian. I think that's a great question because if you look at some of the operators in Asia that are fully intent on having 5G networks within the next couple of years, even if they're pre-standard, they've all had a similar sort of background that they've been working on. The first one that we've realized is they have to stop treating everything as a single class of service or trying to use over-provisioning, for example, as a way to carry bandwidth, simply because the number of applications contending for quality of services is significantly higher now. And the other thing we're starting to see is there's starting to become microbursts in the network of traffic that can impair flows even when there's utilization as low as 20 to 30%. So when these little bursts occur, they take down VoLTE calls, they'll do significant impairments in terms of quality of experience. But just looking at the network on a kind of an average basis, everything looks like it's going fine. So the logical conclusion from those operators was, let's instrument this, let's do it in very fast real time. If you look at SK Telecom, they're monitoring the entire network state every 30 seconds with sub-second information, and they're using that to detect every possible thing they can so they can optimize their network. So I guess the step would be, first let's gain visibility as a foundation so you can build all this SDN control and analytics on top of it.
Okay, thanks very much, Scott. Anything Brian or other Scott wish to add to that, or we'll move on to the next question?
Sure.
Yeah,
I've never thought of myself as other Scott, but I'll take it. The other thing that we see a lot is the idea that you've got to start moving to a flatter architecture. And most people, I think, figured that out a little while ago, but if you're still building the traditional networks where everything is essentially hubbed back to a central location with long strands out to the towers, that's going to be an issue. This 1 kilometer link that was brought up a couple of times here is going to start impacting. Having a flatter network, having routing at the edge, having connectivity at the edge, having the ability for things like SDN or just even the routing plane to connect between towers without having to pull everything back, that's something you should start doing now. Because it's going to be critical going forward.
Yeah, and I can just add a couple of points here, more on the really down into the the nuts and bolts. We talked to a lot of the MNOs around the world, and they're still deploying copper TDM-based backhaul services. So SCH, E3s, and so on. Stop doing that because that won't scale to 5G. If you're going to start deploying 5G with the very high data rates and multiple users at a given cell site, you probably don't want to do a microwave or millimeter wave backhaul. It won't scale. And the other one is a bigger topic. It's the whole CRAN, the cloud or centralized RAN architecture. It's primarily done using CPRI, which is a published standard, or a published specification. It's not really a standard. And it won't scale to 5G. So if you're building out that CRAN architecture, there is an architecture called SplitMac, which will allow you to scale. But if you're going to use a CPRI-based architecture, you're going to have a very hard time scaling to the 5G speeds, just because CPRI was never designed to work with 5G.
Thanks very much, Brian. And just as a note here, IHS will be running a webinar on non-CPRI-based front-haul solutions for CRAN in a couple of weeks' time, so stay tuned for that. Okay, thank you for that question. Our next question focuses on mobile edge computing. And Scott Wilkinson, this was something that you brought up in one of your slides, so I'm going to turn to you first. How will mobile edge computing impact or advance 5G adoption?
That's a really interesting question, because I think the biggest thing about mobile edge computing is we don't know exactly everything it's going to be able to do. But the reality is, when you talk to people about 5G, it's not usually the first thing they bring up. The first thing they bring up is video, and the second thing is usually video, and then they get into video. But after that, they talk about Internet of Things. So the large bandwidth and the large number of instruments is usually what comes up first. But what I think you'll start seeing is, once the mobile edge computing platform is out there, once people start being able to do things with it, once network operators in particular start seeing the value that they can bring to customers with it, then it will start being a driver for expansion of 5G. I'd like to be wrong about that. I'd like to think that people from the beginning would look at this as a driver and would want to build their networks just to be able to enable those services. But the reality is, I think it's the high bandwidth and number of devices for video and for Internet of Things that are going to drive it first.
Okay, thanks very much. Anyone else want to chime in on that?
No, I think Scott covered it quite well.
Okay, great. Well, I've got several questions that are around different technologies for backhaul, some around the possibility for millimeter wave, some around PON. What is going to scale? What's going to be applicable? And we can kind of consider within this question what kind of form factor base stations or antennas we might be seeing within 5G. Brian, picking you up on your comment, you don't feel these are going to scale. Perhaps I can come to you first on these. What are we going to see as the underpinning technologies of backhaul?
Yes, I mean, some of the things can scale, like PON, for example, can scale. My thing was more, or my concern was more down to the actual physical media, where I believe that fiber, if you can get it out there, I mean, if you have to run something, you might as well run fiber and not copper. If somebody wants to run copper, it's probably because it's already there. It might be in the building for an indoor 5G cell, for example. And on the millimeter wave, there is talk about having a 5G radio that will operate in that frequency range. Actually, there's a lot of discussions about what ranges 5G will need and will actually use. The millimeter backhaul I was talking about are the products that are available today that will not scale to the tens of gigabits per second that you'll need to a 5G-enabled macro site. So I think the jury is still out on exactly what technologies will be the dominant ones. There's a lot of vendors obviously at play. They're trying to get into this space or to maintain their mobile backhaul side. Again, I'm a firm believer in the R&D community. There's a lot of ways to skin a cat, And I think that there's no one winner for the backhaul technology. I think it's going to be quite a mix of various technologies based on performance and price points.
Okay, thanks very much. That sounds very comprehensive. Anyone else have any comments to add?
Sure, this is the other Scott, Wilkinson. So I talked recently with a provider, a vendor who had come up with a way of using, especially in North America, the unused UHF spectrum to come up with a way of doing wireless backhaul with antennas and millimeter wave kind of thing, kind of application. And even they would say that in North America, they saw that as an interim solution. They saw it as a way of getting the network up and running, get the kind of bandwidth there until fiber comes into place. North America is relatively unique. They believe that there is an application for that worldwide, especially in places where you can't get fiber in. But ultimately, they all believe that you've got to get fiber out there, whether it's PON or point-to-point.
Okay, thanks very much, Scott. Okay, I'm going to change direction. We've got a question here about 5G wireless being used for fixed broadband applications. Anyone want to jump in on that one?
Yeah, I can jump in on that one. I think that's probably that's the Trojan horse in terms of the applications. So there are some large operators such as Verizon. They're talking about having what do they call it? Pilots sometimes in 2017, and they're looking at using the 28 gigahertz millimeter wave technology. I believe they'll be looking at the FCC for an interim pass to test it out. And I think that could solve a lot of problems, right? Instead of running fiber to the home, you could just bolt a 5G onto the side of the wall or put it on the desk inside, and now you have a very high-speed residential broadband over a wireless connection. The one concern I would have there, this is my personal concern, is if you give bandwidth to people, especially kids in the house, they'll find a way to use it. So what would typically be less used on a mobile device, there's only so many pixels on your screen you can populate, and that dictates how much bandwidth you'll use on your smartphone. If you're going to feed that directly into the home, you're going to be feeding a lot more devices in that home, which will be aggregated through that single 5G point. But that said, I think that opportunity there will both be an easy way to get some new revenues to help fund that 5G network, but it'll also put an enormous amount of strain on the RAN network itself, because it's fairly easy to turn up that 5G, and that bandwidth will likely be used quite a bit.
Okay, thanks very much. I can take any other comments, otherwise I'll be moving on. Okay.
Yeah, Google, of course, recently made a comment about that and said that they were looking at wireless technologies like 5G as perhaps an alternative for Google Fiber, and then they had to backtrack a little bit and say, no, we're still doing Google Fiber. But it did cause a lot of people to start thinking about that as perhaps an alternative. Yeah,
absolutely. Okay, I've got one here that I'm going to direct first to Scott Sumner of Accedian. How long does it take to create a fully instrumented network that interfaces with SDN control and big data and analytics? How does an operator start?
Well, there's a question. If you look at that from traditional probe perspective or metrology perspective, you'd be looking at a couple-year project. You'd want to get started early on this. But with the virtualization of instrumentation itself, we've seen this timeline collapse dramatically. So even some operators that maybe didn't think about all of this at the beginning and started realizing they have to get some visibility across their network. We've seen networks now in the 250,000 endpoints being instrumented in 8 to 12 weeks, and a very short amount of time, and that's basically because the solution can be highly virtualized, run on commercial off-the-shelf servers, and use the existing network elements as endpoints. So when you get that kind of infrastructure where everything is highly virtual, it's low cost, it's efficient, but it also integrates quickly with the other platforms that are on the same data center fabric, so to speak. So the analytics engines, the SDN controllers, all the open source tools that are being used to build the network. So actually what we're looking at now is that this is becoming a much simpler endeavor and also much faster for the operator because they can use their existing staff to kind of stand these things up quickly.
Thank you very much, Scott. A great attempt in a minute and a half to answer something that's probably a webinar in its own right. Okay, well, we've got one more quick question that we're going to take, and I'm going to turn to Brian of Sienna. You mentioned latency. You had a slide on that earlier. I have a question in. How do you think synchronization and end-to-end latency will be achieved in 5G?
Yeah, that's actually a really good question, and it's something that in the discussions I've had with several MNOs, that's a critical concern. Some of the synchronization methods that we have today, we're talking the satellite-based services, 1588 V2. There is some concern or question whether 1588 V2 will actually be performant enough for 5G latency requirements, but the jury is still out on that. I think the latency architectures, the timing architectures that we have today in play with 4G is probably the direction that we're going to head with 5G. And if something, as we get closer to the actual 5G targets once they get standardized, we may have a 1588 V3, but I still think we'll use the satellite-based systems, similar to what we're doing today. But it's a very good question, and there's a lot of discussion and heated debate in the industry right now about the timing of 5G network.
Thank you very much, Brian, and thank you also to Scott Sumner and Scott Wilkinson for their contributions, not just to the Q&A, but to the content part of our presentation. Unfortunately, we have run out of time for any more questions. Our speakers will see all your questions, and they will have the opportunity to follow up with you individually offline. But for now, we're going to be wrapping up the webinar, so I'm going to hand back to our moderator, Alan Tatara.
Thank you, Richard. I want to thank everyone as well for your participation on today's webinar, as well as submitting your questions and comments. Richard, thank you for leading our discussion, and all of our presenters for this very dynamic discussion. An archived version of this webinar will be available shortly, and we'll be sending out a follow-up email on how to access that archive, or you can simply use that same audience link that we sent to you earlier. So feel free to come back and view this session again, or even share it with your colleagues. You're also going to see a short survey pop up at the conclusion of this webinar. We'd love to get your feedback, so please take a few moments to fill that out. And make sure you follow us on Twitter for information on future IHS technology webinars. Again, thank you so much for joining us, and have a great rest of your day.